Hey mathematicians, welcome to a review of scientific notation. Also recognizing that scientific notation was talked about quite a while ago in 7th grade, so I don't want to make the assumption that we all know exactly what's going on. So for some of us, this is a review. For some of us, this is a reminder. And for some of us, this is going to appear new. So as we walk through this, just kind of keep that in mind. That's kind of where I'm coming from. So scientific notation is a way to write really big numbers and really tiny numbers. That's why we use scientific notation. It's to be able to take those numbers, instead of having 40 zeros, we can condense it, right? So that's what we're talking about today. And when you set this up, right here is a number that is going to be greater than or equal to 1 and less than 10. So in other words, one number before the decimal. Like how I brought in compound inequalities for this, right? So it's gonna be 1 or greater all the way up to 9.99999 and so on, all right? And then this is gonna be my exponent. It's gonna be my power of 10. So scientific notation would be like 3.2 times 10 to the 5th, or 3.8 times 10 to the 19th, or 2.5 times 10 to the negative 8. Those are all examples, okay? All right, so here we go. We want to express this really big number in scientific notation. So this is how we do it. First of all, the decimal can only have one number before it. So 4.062. All right. And then it's going to be times 10. Now I need to come up with my exponent. And my exponent is how many spaces I have to move the decimal. So if the decimal starts right here, I move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is going to be 4.062 times 10 to the 12th. All right. The 12 is positive because I'm moving to the right. This next problem, my decimal is going to be moving to the left. So I'm going to have my decimal goes here, only one number, one non-zero number before the decimal. So it's going to be 8.26 times 10. Now I have to figure out how far do I move the decimal to get to where it needs to be. I move it backwards, 1, 2, 3, 4, 5, 6, 7. It's going to be to the negative 7th because I'm moving it back 7 spots. 8.26 times 10 to the negative 7. In both cases, I only have one number in front of the decimal. Let's try another one. All right, so my decimal, I can only have one number in front of the decimal. And now to figure out my exponent, I figure out how far do I move those numbers. So 1, 2, 3, 4, 5, 6, 7, 8. 4.58 times 10 to the 8th. Again, only one number in front of the decimal. We're going to move it back 1, 2, 3, 4, negative 4. 4.52 times 10 to the negative 4th. All right. Now that we've worked from going from standard form or decimal form to scientific, we're going to talk about going from scientific to decimal or standard. So when I've got 6.49 times 10 to the 5th, that means I'm going to move the decimal 5 spots to the right. So 1, 2, 3, 4, 5. I fill in my zeros. So my answer is 649,000. Standard form and decimal form are the same thing. So you'll see it, you'll hear it referred to in both cases. All right, so here's the next one, 1.8, it's 10 to the negative 3. That means I move it back 1, 2, 3. The negative tells me to move it back 3. So 0.0018. This is my standard form, or also known as decimal form. Okay. All right, we're going to write this one in standard form. It's a positive 8. That means I move the decimal 8 spots to the right. So I start at 1.904. Here's my decimal, 1, 2, 3, 4, 5, 6, 7, 8. So I put all my zeros in there, and now it looks like I've got 1904, 1, 2, 3, 4, 5. Now, I am going to be picky. If you leave your answer like this, that is going to be marked wrong because it has 2 decimal places in it. So I need you to make sure that you're writing out the correct answer and boxing it in. So be really careful with that. 9.1 times 10 to the negative 6. I move it back 1, 2, 3, 4, 5, 6. So 0.1, I'm going to put in 5 zeros, 9, 1. There we go. Okay. All right, so what we're going to do here, it's going to take us a little bit step further. We're going to multiply and divide numbers that are written in scientific notation. So what we're going to do is we're going to get out our highlighter, and I'm going to take the 5 and the 2, and then I'm going to work with the 10 to the negative 6 and 10 to the 12. So this is tying in what we talked about with multiplying exponential expressions. So I'm going to start with the 5 and the 2. 5 times 2 is 10. Then I'm going to work with my 2, 10 to the negative 6 and 10 to the 12. When you multiply powers, you can add their exponents. So negative 6 plus 12, that's 10 to the 6th. All right. Now we want it in scientific notation and standard form. What I have right now is neither, because scientific notation can only have one number in front of the decimal. And so what I'm going to end up with is I'm going to write it out in standard form first. So I've got the 10. I move the decimal 6 places to the right. 1, 2, 3, 4, 5, 6. So I'm going to fill in my numbers. So it looks like I have 10 million. That's my standard form. Now I'm going to take that and put it into scientific notation. And with scientific notation, there's only one number in front of the decimal. So 1 times 10 to the 1, 2, 3, 4, 5, 6, 7. It's going to be to the 7th power. So what I have is my scientific form and my standard form. Let's go ahead and do another one. Again, same thing. I'm going to highlight just because it helps me keep things a little more focused on what I need to work with. So 8 times 3 is 24. 10 to the 3rd times 10 to the 5th is really going to be 10 to the 2nd. And so that's not scientific because I don't have one number in front of the decimal. So to write it in standard form, I'm going to have 2, 4, and then I got to move the decimal 2 spots to the right. So 2, 4, 0, 0. That's my standard form. And then scientific notation, only one number before the decimal. It's 2.4 times 10 to the 3 to the 3rd. Okay. Now we're going to expect that you can do this without a calculator on your test. You're going to have to show your work. So just be aware of that. Now division is going to be the same thing. Division is going to be the same thing. Again, highlight common parts and work with that. So 4 divided by 2 is 2. 10 to the 8th divided by 10 to the 10th. When you divide powers, you can subtract the exponents. So it's 10 to the negative 2. 2 times 10 to the negative 2. Now, to write it in standard form, I'm going to have to move my decimal 1, 2 to the left. So 0.02 is the standard part. Right? Again, let's take a look at this. 4 to the 8. And then here we go. So 4/8 is going to be 1/2 or 0.5. And 10 to the 5th minus 10 to the negative, or divided by 10 to the negative 3 is 10 to the 8th. 5 minus -3 is 8. Now, this isn't scientific notation because I only have one, I don't have any numbers to the left of the decimal. So I'm going to write it out in standard form first. That usually helps me. So if I'm going to move it 8 spots, 1, 2, 3, 4, 5, 6, 7, 8. So 5 times 10 to the 1, 2, 3, 4, 5, 6, 7 to the 7th. Okay, there's my scientific form. And then to write it in standard form, 5, and then I have to have 7. 1, 2, 3, 4, 5, 6, 7. Here we go. So it's going to be 50 million. Okay. All right. And that's where we're at. So you'll have time to work. We will not be going on to geometric sequencing. That is something we've decided we don't need to do this year. You will have an opportunity to learn that in the next couple of years. So that's it for today. And I hope you have a fantastic day. We'll start getting ready for our assessment. Take care.